Hi guys, in this video we are going to discuss about bubble sort and merge sort. Okay, so basically our today's agenda is we will discuss what is bubble sort, what is merge sort. Okay, how to implement bubble sort, how to implement bubble sort. We will just see the algorithm. Okay, we will not see the code, we will see algorithm. How to implement bubble sort and how to implement merge sort. Okay, what is the time complexity? Time complexity of bubble sort and same for merge sort. Okay, so basically we are going to compare these two sorting algorithms. Okay, so let's get started. Firstly, we will discuss about bubble sort. Okay, so remove this. We will discuss about bubble sort. Okay, kept it here. Now, what is bubble sort? Let's say we are having an array. We will take short, small array. Okay, we will not take larger arrays. 5, 1, minus 0, minus 0. Have you seen this number? Minus 10, 11, 12, and minus 50. Okay, so these are the numbers. This is an array. What we have to do? We have to sort this array. We have to sort this array using bubbles. Using bubble sort. So just remember one thing. Just remember one thing. What bubble sort does? Bubble sort at each and every iteration, bubble sort helps the maximum number to reach at its correct index. Understood? So what I will just explaining it shortly. In first iteration, our array will be basically we will get the maximum index, maximum value, which is the maximum 12. So we will get 12 at its correct position. In second iteration, what is the second max? 11. So we will get 11 at its correct position. And similarly, in the particular iteration, we will get the whole array sorted. Okay, so this is how bubble sort works. But let's see the working. Let's see the algorithm. Okay, in first iteration, what we'll do? We will start from every time. We will start from 0th index. We will compare 5 and 1. These two will get compared, and the shorter number, the value which is shorter, let's say 5 is at correct position, no, 5 is bigger than 1, so we will swap these two values. So uh, let me manage this. Yeah, first iteration first iteration. Okay, first pass, these are passes. Okay, so what will the value in the first pass? 1 and 5 will get swapped. Okay, so 1 here, 5 here. The rest of the array will get remain same, 11, 12, and minus 50. Okay. Second pass. Second pass. We will see how many passes will be there. Okay. Now 1 and 5 is swapped. Okay, so 1 is here, 5 is here. Okay. Now we will compare these two elements. We will compare these two elements. Okay. Firstly, these two elements are compared. After that, these two elements will get compared. After that, these, and these. Okay. So 5 and minus 10. The smaller value. If 5 is smaller than minus 10, no. So we will swap these two values. So we will swap these values. 1 minus 10, 5, 11, 12 minus 50. Okay. Now third pass. Third pass. Okay. Let me remove this. Minus 10 and 5. Okay. Now these two values will get compared. 5 and 11. We can see 5 is smaller than 11. So these two values are at correct position. So we will write simply exact same error. Minus 10, 5, 11, 12, minus 50. This is third pass. Fourth pass. Okay. These two values will get compared. These two values. 11 and 12. 11 and 12. They are at their correct position. So again same array. 1 minus 10, 5, 11, 12 minus 50. Okay, after that 12 and minus 50 will get compared. 12 and minus 50. Okay, so 12 is bigger than minus 50. So just swap these two values. Fifth pass. Okay, what will be our array? First 1 minus 10, 5, 11, 12. Oh, not 12, not 12. It will be minus 50. Minus 50. Values are swapped. Minus 50 and 12. So this is our first iteration. This is our first iteration. And what we get from it, we got the maximum value among this array at its correct position. At its correct position. So 12 is at its correct position. And how many passes we have taken? How many passes we have taken? 5. 5. 1, 2, 3, 4, 5, 6. There are 6 number of elements, and we have taken 5 iteration, 5 passes. So there is a combination in between iteration and passes. If we are at first iteration, then the total number of passes will be n minus iteration. Okay, at any iteration. If we are at first iteration, total n is 6. So 6 minus 1 is 5. In second iteration, you will see there will be only 4 passes. There will be only 4 passes because 12 is at correct position. 12 is at its correct position. We just have to compare these two values. We just have to compare these two values. We are not required to compare 12 again and again because 12 is at its correct position. Okay. So a new array will be, I am writing the second iteration. Second iteration. Okay. Now what will be our array? Let me write this. Our array will be 1 minus 10, 5, 11, minus 50 and 12. Okay, this is our array. Now first pass. Okay. Now 1, 2, 3, 4, 5, 6. Okay, first pass. This we will not consider this. I'm making a cross. Okay, because 12 is at correct position. Second iteration. Now this will be compared to this. 1 will compare itself with minus 10. 1 is greater than minus 10. So these value will get swapped. Minus 10, 1, 5, 11, minus 50 and 12. Okay. Second pass. 1, 2, 3, 4, 5, 6. Okay. Now, values are swapped. So, minus 10, 1 and 5. These two values will get swapped. No, not swapped. These two values will get compared. 1 will get compared with 5. 1 is smaller than 5. So both are at their correct position. So minus 10, 1, 5, 11, minus 50 and 12. Easy. Third pass. Now 1, 2, 3, 4, 5 and 6. Okay. In this, these two values will get compared. 5 and 11. 5 is smaller than 11. Correct position. Minus 10, 1, 5, 11, minus 50, 12. Okay. Fourth pass. 1, 2, 3, 4, 5, 6. Okay. 11 will get compared with minus 50. 11 is greater than minus 50. So we have to swap. So what we will do? Minus 10, 1, 5, minus 50, 11 and 12. Okay. So you can see this is all about the second iteration. You can see there are total number of 4 passes and 11 is at its correct position. 12 is also at its correct position. So we got two numbers at their correct position. Similarly, this algorithm will get followed and the total number of iterations it will take. Because in first iteration, one number got sorted. Okay. In second iteration, second number got its correct place. Okay. At third, I am writing the answer of third iteration. What will be the resultant array in third iteration? This will be the resultant array. 2, 3, 4, 5, 6. 11 and 12 are at correct position. 5 will reach here. After that, minus 10 will stay here. 1 will stay here and minus 50 will be here. This is the answer. I want you I want you to follow the same process, same algorithm, and create all the iterations in your copy or in anything. Okay. Uh, this is our third iteration. Now I'm writing fourth iteration. Fourth iteration, resultant answer. Fourth iteration, resultant array. 2, 3, 4, 5, 6. 11 and 12 and 5 will remain same. 1 will reach here, minus 10 will stay here, and minus 50. This will be the resultant array of fourth iteration. Now, fifth iteration. Fifth iteration, okay. Fifth. 1, 2, 3, 4, 5, 6. Here, 1, 5, 11, 12. These will remain same. Minus 50 will come here, and minus 10 will come here, and you can see array is sorted. Total number of 5 iterations. 5 iterations will be required. Okay, and you can see array sorted because you are not required to create 6 iteration, because 6 iteration will sort minus 50 at its position, so there is no need. Okay, so 5 iterations are required, and each and every iteration is having n minus itr number of passes. So basically the time complexity of bubble sort is n into n minus 1, n into n minus 1. These are the total number of iteration or time complexity. So basically n square minus n, and in front of n square n can be neglected, so our time complexity will be n square. Okay, big O of n square. This is the worst time complexity for bubble sort. Okay, so I hope you guys understood what is bubble sort. I want you to write each and every iterations and each and every passes. Okay. Now, now, now we are going to discuss about merge sort. Okay. I hope I have explained enough about bubble sort. Now, merge sort. Merge sort. Okay. What we will do? Let's say we are having array. We are having array 1, 2, 3, 4, 5, 6. The same array. Should we take the same array? We can take 1 minus 10, 5. We can take 1 minus 10, 5, 11, 12, minus 50. Okay, we have taken the same array. What we have to do? We have to merge sort this array. We have to implement merge sort. Now, there is a total difference between merge sort and bubble sort. What merge sort do? The space complexity. The space complexity of bubble sort is big O of 1. Order of 1. That means no extra space is required. But merge sort requires space. Merge sort requires space because we are going to create a new array. At every time. Okay, I will explain you. This is low. This is high. Okay. 0, 1, 2, 3, 4, 5. 0 plus 5 by 2 equals to 2. So this will be our mid. What we will do? We will divide this array into parts. Okay, we will divide this array into let's say 0 to mid, then mid plus 1 to high. So our two arrays will be 1 minus 10, 5. This is our first array, and 11, 12 minus 50. This is our second array. Okay. Again we will divide this array again. So this array will get divided into two parts, 0, 1, 2. So 0 plus 2 by 2 is 1. So minus 1, not minus 1, 1 and minus 10. And here 5 will come. Okay. This array will also get divided into two parts, 11 and 12. And here minus 50. Again 0, 1, 0 plus 1 by 2, 0. So basically divide this into two parts, 1 minus 10. This will remain same, 5. This will get divided into two parts, 11, 12, and this will remain same. Okay. So we have created 1, 2, 3, 4, 5, 6 sub arrays. We have created 6 sub arrays. Okay. And then now what we will do, we will combine them. These two will get combined. Okay. uh basically wait for some time. Yeah. Okay. We will combine these two and we will sort them. This will remain same. We will combine two. And sort them. This will remain same. After that, these two will get combined. Combined means we will create a bigger array of size, the total size of both of the arrays. Okay. After that, we have to sort them. Okay. Yeah, this is okay, and this is also okay. After that, we will combine these two and we will sort them. Okay. So let me explain again what we will do. 1 and minus 10 will get combined and will create an array of size 2, and we will sort them. So 1 and minus 10. No. Minus 10 and 1. Minus 10 and 1. Minus 10 and 1. Okay. This will remain same. So this will come 5. We will combine these two. 11 and 12. This will remain same. Minus 50. After that, these two will get combined and an array of size 3 will get created. Understood now? Why the size of 3 will get created? 2 plus 1, 3. And just sort them. So 5 will get compared to minus 10. It is greater. 5 is so this will present here. 5 will get compared to 1. 1 is smaller. 5 will stay here. After that, these two will get compared. 3 minus 50 will get compared with 11. Minus 50 is smaller. 11 will get compared with 12. 11 is smaller. 12. Okay. After that, these two arrays will get merged. 2, 3, 4, 5, 6. You can understand now. We are basically merging the two arrays. Firstly, we have separated each of the element, and then we are combining them. We are merging them. Okay. Now we will simply sort them. So minus 50, minus 10, 1, 5, 11, and 12, and we will get the required array, the sorted array. Okay, this will be our answer. So this is how we are going to sort the array using merge sort. Okay. Now, can you tell me the time complexity? The time complexity will be n log n. We go of n log n. Okay. How? Because we are sorting. You can see these three. These are the division, and these are the joining, merging part. Okay. What we are doing? There are three steps. Total of elements 6. So log 6 is greater than 2. That means 3. Okay. So that's why log is written, and we are combining each and every element. We are sorting each and every elements. So there are total of n elements. So n log of n. Understood? But this time complexity is much smaller than n square. But the space complexity is very high. Okay, it takes a space of around O of n, big O of n. Okay, because every element is considered as an array. That's why the space complexity is very high. Okay, so I think I have explained much about merge sort and bubble sort. I hope you guys understood the problem. We will meet in the next video. Until then, bye.